Hello Year 10, this is Mr. Bay here. Just wanted to run you through a practical which I was actually going to get you to do last week, but we are now stuck at home. So this is on precipitation, and if we remember back to our lesson on precipitation, precipitation is the chemical reaction where two solutions that contain dissolved ions mix together, and when these ions come in contact or they react, in some cases the attraction is strong enough to form ionic bonds, and therefore we get a new ionic compound. And sometimes that new ionic compound is not soluble in water, okay? And we call that term insoluble. And the way we know we have an insoluble substance is we see a color change, okay? Color change, we see a precipitate made in particular. Hence why we call precipitation reaction. The thing we get out of it is a precipitate, all right? And as you can see below, I have got a table with lots of different chemicals. All right, so in particular, the top row is actually the anions. So if we go back and remember our basic stuff from last year, an anion is the negative ion. All right, now what we have down the left-hand side is actually the cations. And if we remember back as well, cation, or cation as I used to say, is the positive ion. All right, so in this case here, I have got a bottle or a dropper that contains every single one of these compounds named. So on the top, we go from nitrate, chloride, sulfate, carbonate, acetate, hydroxide, and then going down the left-hand side, we have sodium, silver, lead 2. So lead 2 means in its ionic form, it'll be 2+. All right, magnesium, nitrate, magnesium nitrate, iron 2, we don't actually have any of that, so don't worry about it. Copper 2, again, when you see that 2 in Roman numerals, what that means is the ion that comes out will have a 2+ charge. Zinc, aluminium, barium, nitrate, calcium, and iron 3, which I actually have. So what you can see here, all of these chemicals are in dropper bottles like this, and they are actually see-through liquids. All right, so all these chemicals here have a soluble. It's a soluble, okay? So these compounds are not insoluble, hence why the liquids are see-through. So what we're actually going to be doing is, we're going to be seeing if we cross sodium here, which is our cation, which is coming from sodium nitrate, with potassium nitrate, it means that in our reaction, we are going to get some pairs of sodium nitrate. But if we see that the liquid is still colorless and there's no precipitate, it means that sodium nitrate is actually a soluble solid. All right, so I will actually get the potassium nitrate here ready to go. Actually, sorry. I will do silver nitrate. Oh, what am I on about? Mr. Bayer, what are you doing? You got no clue. Now, so what I have here is, we could do like the makeup beauties. So sodium nitrate is 1 mole, and there is the chemical symbol for this. So NaNO3. All right. Now what I'm going to do is I'm going to put a few drops, let the camera refocus, across each of these squares. All right. Ooh, probably a bit too much. So probably put about 2 drops on each. As you can see, this is really difficult work. Great, so 2 drops each. So across that column, on this side here, we have sodium nitrate. Now I'm going to mix it with potassium nitrate. All right, so KNO3. Now, we can probably estimate here that nothing's gonna really happen, all right? But we'll see what happens. There is no chemical reaction. All right, so what we can show there is that even though we've swapped cation and anion, we still have no insoluble compound. All right, I will tie potassium chloride with it now. So what that means is we're gonna get sodium chloride as being a solution here. But guess what? We think we already know that salt and water does not make anything. All right, next one as well, we're gonna hopefully have sodium sulfate be produced. And we'll see if that is a compound we have. Now, again, still white. We have now sodium carbonate. So again, just a couple of drops. And again, I cannot see a reaction live. Next, we're going to do sodium acetate. All right, so this is the acetate ion, the CHCOO negative ion with Na plus. So that's why they come together. So a big complex name for them is actually sodium ethanoate. All right, but we just call it acetate, sodium acetate. Or acetic acid as well. Not acetic acid, don't worry about that. Again, no change. And we're going to finally have sodium hydroxide, NaOH. So this should make, again, more sodium hydroxide. And again, we have no color change at all across any of these reactions. All right, so what I'm going to do now is I'm going to speed it up a little bit. And I'm going to fill the whole first column with potassium nitrate going down this way. All right, and so on and so forth. So give me a moment. So we've done the huge row of sodium. All right, so we can show you, it says that all sodium salts, so sodium nitrate, sodium chloride, sodium sulfate, sodium carbonate, sodium acetate, and sodium hydroxide are soluble in water, which means that there will be no product of a sodium atom, at least in this case. There are some examples, but they can get quite complex. Next, we're going to add silver into this, okay? So we can probably already guess, all right, that the silver nitrate reacting with potassium nitrate is not going to do anything. Because even if they swap partners, the potassium and the silver, you're not going to get anything. So we'll see what happens. So nothing there. Ooh, silver chloride, there was something. It's gone a milky white. Sodium sulfate, no. Ooh, silver carbonate looks pretty good. It's gone milky as well. Of course the lights go off and I'm trying to film this. All right, so again, sodium acetate, nothing's happened as well. And sodium hydroxide, ooh, look at that silver hydroxide. We've had a nice color change. So I'm gonna zoom in a little bit and show you. So silver nitrate. We've had a little bit of cloudiness, but I believe that's probably to do with the silver than anything else. All right. We can clearly see there, silver chloride is a nice milky color. All right, sodium sulfate, again, we've got completely clear. Sodium carbonate, we have got a milky solution. So that shows you we've had a precipitate formed. Sodium acetate, nothing, which means silver acetate has nothing. And sodium hydroxide, we can clearly see silver hydroxide is being produced and we get a nice brown color, which shows you that's a precipitate. Next is lead, all right? So we're doing lead nitrate. So this stuff is kind of toxic. So what should I be wearing? Ooh, we've got some good reactions there, all right? So, I can already see 3 that have produced a precipitate, and in particular a white precipitate. Okay, so if we go down, lead nitrate, we have no precipitate. Lead chloride, we've got slightly something there, but probably no. We have a clear result with sodium sulfate and lead nitrate, which means lead sulfate does make a precipitate. We've got lead carbonate, we can clearly see as well a precipitate. Lead acetate, there is nothing, and sodium hydroxide, so lead hydroxide is a solid, all right, which shows you a precipitate, which means it cannot be dissolved. Next, we'll do magnesium. Make sure to ring that bell, okay? And again, I have got absolutely nothing there. They are all still colorless and clear liquid, showing that all magnesium nitrate, chloride, sulfate, whatever, are all soluble in water. Next, I'm going to do copper. This is going to make some extremely nice colors because copper salts are quite colorful. We already knew that in our corrosion prac, right? Because we've clearly seen that we get a nice verdigris, which is what turned, okay, I was going to say Eiffel Tower, but it's not the Eiffel Tower. It's what turns the Lady Liberty in New York. But we'll do this now. So copper sulfate is going into copper nitrate. Now this is coming out a little bit blue, which shows you it has unfortunately already reacted a little. Oh no, it should come out blue. That's what it should be, don't worry. So it's blue in color, which shows it's dissolved. Oh, we get some lovely copper carbonate there, all right? Or copper hydroxide, have a look at that, okay? So we've got some really, really cool colors there. So again, this one here has still colorless, precipitate, colorless, precipitate, all right? Next is good old zinc chloride. There's not much in this bottle, so let's see what I can get out of it. Nothing, which shows that probably all of these zinc compounds are still soluble in water. Sorry, these zinc compounds. Next, I'm going to do aluminium sulfate, all right? All right, so we have slight precipitation in 2 of them. So in the aluminium carbonate, we've got a little bit there. Definitely in the aluminium hydroxide, but the rest are colorless, all right? Next is good old barium, all right? I had to do a bit of a dodge job here, but we'll see what happens. This is barium. Ooh, got a very nice reaction there. Ooh, same thing as well. No barium for carbonate, for acetate, and hydroxide as well. So, as you can clearly see between these two, the barium sulfate has made a precipitate, and the barium carbonate has also made a precipitate. Next, we're doing calcium nitrate. Again, I don't know the molarity of this, so how strong it is, but I wouldn't be surprised if it was 0.1 like the rest of them. So let's see what happens. Nothing there, nothing there, nothing there. Ooh, precipitate straight away there. Cool. So with calcium, it was only calcium carbonate that became a precipitate. Oh no, ours have mixed down the bottom. So I was going to do this one. Actually, no, we have also got calcium hydroxide has also produced a precipitate. All right, so we'll get a bit closer. Clearly you can see there and there, but unfortunately our solutions have mixed together, so I've now had to add a new one down the bottom. And lastly, but oh no, look at this. The bottle's literally got nothing in it, the boys. All right, here's the peak. As you can see, this iron 3 is automatically a yellow color. All right, so therefore we need to take that into account. Just reacted with calcium. Oi, very nice. Alright, so from that I can clearly see, again, iron carbonate, iron 3 carbonate, has reacted to make a precipitate. Sodium acetate, kind of look like it has, but I don't reckon it has, but definitely iron hydroxide is definitely non-soluble. Alright, cool. Thanks guys, that's been Mr. Bay's dodgy chemistry at school. Boy. Hi all, so this is something to do with our precipitation reaction. So what I want you to do is I want you to, for each of those reactions which did produce a precipitate, I want you to write out the equations for it to work. All right, so in particular, one I know that definitely worked was silver nitrate. All right, so AgNO3, and it reacted with NaOH, which is actually sodium hydroxide. All right. So when this reacts, okay, we have made a solid. So in this case, we talk about the units. That is AQ. That is AQ. AQ for aqueous. And in this case, we get AgOH because this group and this group have reacted together because these are ions. So now this becomes solid. Plus, what do you reckon's left over? Yes, you are correct. Sodium nitrate. All right, and that is still aqueous as well. All right, or that's the general one, or if we wrote the ionic equation, or sometimes we call it the full ionic, it is Ag plus, because that's what iron will turn into, plus NO3 negative, plus sodium plus hydroxide group. And at the end of this, we get AgNO3. Now the reason why is that is now an insoluble compound, which means it's no longer is an ion because it's no longer in solution. You could use something else besides water to make it go and dissociate and become its ions, okay? But in water, it does not work. You could use something like ethanol, some other liquid, all right? But in this case, it stays like this because it is a solid, and then what's left over is, of course, the Na plus and the NO3 group, all right? Oh, why did I put that up there? The NO3 negative group, and that's how we get that, all right? So can we see how we get to those equations? Oh, I just realized I missed the whole silver. But you can clearly see there that Ag is the silver. All right. Man, this is... Have I still got this zoomed in? No, I don't. It's just a big board. But as you can see, this is how we got the reaction. So silver, nitrate, sodium hydroxide becomes silver hydroxide plus sodium nitrate, aqueous, solid, insoluble. Full ionic, ion, 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 reacting together, both were colorless liquids. You get silver nitrate out of it, which is a solid, plus sodium plus nitrate ions. And guess what? They stay in solution because they have not been precipitated out. What we could do is if we were to filter this solution, you'd be left with a residue inside of that filter paper of this silver nitrate. And guess what would go through? The liquid with these ions. And what you could do is, if you were to distill it, or boil it to get rid of those compounds, you would then end up getting this with sodium nitrate powder, all right? Because it probably would turn back to a solid. All right, hopefully this works for you.